Morning, everyone. So today we want to focus on that most people think inventor nesting is related to sheet metal, but it's not. Our agenda today, we're going to do two types of demo. Demo one is kind of almost the same that we did with the inventor nesting for sheet metal on Tuesday, but we're going to look at some different things. And then another demo we're going to do is what I call the saw method. This is something that you may not even think or consider being a nesting, but I think it's a helpful tool. And then at the end, we'll have a Q&A session. Inventor nesting, as I stated nesting in our Tuesday webinar, there's actually two products. There's inventor nesting and then there's true nesting. Our focus for these two webinars this week has been on inventor nesting. Again, it's part of the product design and manufacturing collection. It is a separate download that you must install, or it's an add-on for an inventor. Just because you install the inventor doesn't mean you get inventor nesting is there. There was a couple questions about this. Inventor nesting started in the 2019 release or newer. Again, it's just 2D. It's not doing CNC stuff. It's just laying out your components on the raw material that you're providing. Again, it's a separate file. Kind of thinking of it like an inventor presentation file. It does have its link to the parts, to the assemblies that you're using, but inventor nesting is a separate file that you maintain. And again, once you've created that nesting, you can export it to DXF, back to a 3D model, and then take it to your CNC information to cut out the layout. 3 ways to start again. Just want to reinforce this. We're going to, through the template, and you're going to kind of see that using the, in demo number 2. From the model, we didn't really show that on Tuesday, but our demo that we're going to show how you can start it from the model, and then the nesting interface the same way that we did it on Tuesday. All right. One of the things that I wanted to go more in detail this time, instead of what we did in sheet metal, is the provider. All right. There's different types of providers for the nesting. So one is AutoCAD DWG, and I talked briefly about this on Tuesday, but I wanted to give you more in depth because usually when you're dealing with sheet metal components, you're not getting into DWG, DXF, those type of things. But today you're going to see how I can bring DWG, DXF into our nesting environment. So just keep in mind that it has to come from model space, and it is geometry only. So for example, I have an image of a plate or a U-bolt plate that came from a master car, all right? So I get all the, the title block, dimensions, notes, those type of things. You have to strip that down. So you have to get rid of everything that you don't want to participate in that nesting, or you're going to get a lot of warnings and errors associated. Also, the shape, whether it's DWG or DXF, has to be a closed 2D profile. All right. Sometimes you may, get my MasterCard drawing. There may be, it's not perfect on corners, those type of things. So just keep that in mind. When you're dealing with providers of DWG and DXF, because it is only 2D geometry, inventor nesting will not know what the thickness is, so it defaults to a 0.12 inch thick material. And I'm basing this, because we're talking about inch units. It would be different, if you were using a template that had metrics for nesting. All right. In our Tuesday webinar, we use an inventor assembly, our toy trucks, to do our sheet metal. The key with inventor assembly, when you select it, it must have at least one accurate or provided inventor part file that meets the requirements, their extrusion. So if you have an inventor assembly that have virtual components in it, or maybe it's an inventor part file that you have, you started a part but you haven't really defined it, then it's just going to bypass it. It's not going to see any information that it can extract under that assembly. However, you can, even if you have sub-assemblies in your model, you can exclude them from nesting, just like how it showed you in Tuesday webinar, how we had that one sheet metal part that we're no longer really creating it as a sheet metal part. We're buying it as a tube, cutting it, but I didn't want to redesign the part and get rid of it as a sheet metal. We just excluded it from nesting. You can do that with assembly. When you exclude the assembly, you exclude all the parts or all the components underneath that assembly in the nesting process. All right. When we get into Inventor IPP, we kind of did this with the sheet metal, but now we're just talking about normal Inventor part files. We're not talking about parts that were created as sheet metal. Again, you can exclude them from nesting, but if a component has an Inventor bill of material structure as purchased, it will automatically exclude it from the nesting. So there's two options that you can exclude from nesting. Right mouse click on it and say exclude from nesting, or set its bill of material structure to purchase. Because when Inventor, you are using a purchase Inventor component, well, it knows that you're buying it. You're not making it, so it automatically excludes it from nesting. All right. This is how it works, again, outside of the sheet metal aspect, where the sheet metal, we actually need a flat pattern. In normal Inventor part files, what it does is it first looks for the last unconsumed sketch. It must be visible and the last node in your browser tree. So if it meets that requirement, the first thing it checks, it's going to use that sketch as its source to be parallel to the nesting plane. If it does not find that, then it goes and gets the first extrusion information from your model browser. All right. When it goes to determine the thickness, if it's finding that first extrusion, it is based automatically on the distance or the length or that length of that extrusion. So if you do your first sketch, your first extrusion, and you extrude it, let's say 10 inches, if you put that part in the nesting, it's going to assume that you are cutting a 10-inch piece of material. All right. We're going to show you a little bit later on how you can change that. That may not be what you're really looking for. If you use any other method to extrude to, like two necks, to, in between, those type of things, yes, in theory, there is a distance for that extrusion, but you didn't put anything in. It defaults to a 0.12 inch thick because it does not truly know, the Inventor nesting does not truly know what that true length is. So just keep that in mind. And you're going to see later on, like I said, we can redefine the source. We can pick as a different extrusion, or we can go pick another sketch. And you're going to see that in our demo, our first demo, how we're going to say that, yeah, you picked this, but I really want to use this source as the in the nesting. Providers, the Inventor Generic CAD, it's basically anything, you bring in STEP, IGES, SolidWorks, ProE, anything that Inventor can work with, you can use in nesting. The key here is you have to save and convert it. All right, so yeah, it's still a Inventor part file, Inventor assembly, but it's not something you actually designed or modeled inside Inventor, so you don't have that model browser history, all right? And that's the information it uses. Again, you can exclude those. And when it's the generic CAD source, you're going to see in my demo here that the information I'm using actually came from GradCAD. It was a SolidWorks assembly in part files. That what it does is to determine its nesting information, it has to look at the file and look for the largest planar face. It uses that face as the parallel face to the nesting plane. All right. It then goes and does a geometry extent check to determine the thickness that's there for the automatic thickness. Now, again, it may not be correct, and you may have to go into the nesting authoring and change it and define it as a different thickness. But we're going to show that here in a few minutes. Again, I'm not going to go into, this is the same information. You can start with templates. You have your process material. You can, you'll get the reported in, you export it out to DXF, 3D, and send it to your CNC machine. All right. With that, we're going to turn it over, and we're going to do demo number 1. So as you can see here, I have a wooden Adirondack chair. It's made out of cedar. Again, I'm not taking credit for doing this model. It was off the GrabCAD website. And what we're going to do is we are going to start a nesting study on this. All right, we're going to lay this out so we can start using maybe a CNC router to cut out our components that make up this Adirondack chair on a piece of, cedar panel. All right, whatever that thickness needs to be. Now, one of the interesting things here is every component here is basically, a single item except the back of the Adirondack chair. Whoever modeled this did it as a single part file but multi-lump. The Inventor Nesting is smart enough to know that because these are individual solids, that it will extract each one of these solids or one of these bodies as individual parts. So it will nest and make, so you would think that it's going to try to nest just this as a single. It actually will nest these all individual multi-lumps as a single component in the nesting. Like I said, if I go to start a nesting, I can go to the home screen like we did on Tuesday. We can click on the nesting tab, or we can go File, New, and start a template. Now, there's a new template in here. If you were here Tuesday webinar, you might not have noticed. It wasn't there. Today it is, because when we get to demo 2, I'm going to show you how we're going to use an existing template that I defined with information for that demo. All right. So basically in this, we're going to right mouse click on here, and we're going to start the nesting study from the actual model. So we're going to say create nest. And then it's going to come and say, okay, what do you want to start it from? So we're just going to leave it as the standard nesting template. Nothing in it, just it's, inch units. There's no material definitions, those type of things. Just like how we showed on Tuesday, it's bringing the source files in, extracting information, comes back and says, okay, here's the material that is associated to it. Do you want to bind to it? And we're going to say, yep, we're okay. And then, like I said, it's going to go through the process of extracting all the information from it, all right? Like I said, the goal on Tuesday was that we want to get all the green check marks here. Now, in this case here, it's going to be a little slow. You can see that the source providers are generic CAD. When you have components, the more components that you have is listed as a generic CAD provider, the longer this extraction will take. Not saying it's going to add hours to, to this time, but remember what I said is when it's generic CAD, it's got to look for the largest linear face, then once it finds that, then it's got to do an extents test to determine what the thickness of that component is. So just keep that in mind when you have generic CAD source provider as that source. It's just going to take a little bit longer to go through because it's got to check every component, every face, see is that the largest face, and so on. So we'll give this here a few more minutes to let it go through. And like I said, we're looking for those green check marks. And as you can see, it based on the material thickness, it's defining those materials. Again, you're going to see in demo 2, you would have your materials defined, because right now I haven't, unless I jotted down that message, I don't know really what material ID to, what's its thickness, those type of things. Again, we're just using the out-of-box template. As you can see, there is no red mark, so we can hit the error log again. Wish it was a little bit more descriptive and say, hey, no issues, but that's your final check that, it's there. All right, we're going to hit OK. Just like before, you're going to see all the components that make that up. Again, this is pre-information. We're not, we haven't laid anything out for it. So, in one of the parts, we may want to say, hey, when we do this, we want to add like some extra material. I'm thinking of wood. if you cut it out, you may, you cut it a little bit larger and you sand it down to the finished dimensions. So if we're going to say, let's say this example, this part here, hey, we've discovered that when we get it cut right straight to the finished dimensions, maybe we have some issues. So we want to add some material to this component, so when it goes in the nesting, we cut it a little bit bigger. But I don't really want to go remodel it again. So what you can do, as I stated before, you can control what it's using for the nesting properties. So we're going to go to nesting, and I know this is the component that we are, but if you don't know, you can click on it, and then it's going to highlight here in the nesting browser. We're going to right mouse click on this and say open. Inside of here, as you can see, that I have a sketch, but it's not visible right now. It's called unfinished. It's basically a sketch of this outline, and then it's offset a 1/4 inch. So I'm adding 1/4 inch material around this entire component. So what I'm going to do is turn the visibility back on. So there's my sketch. You can see that it's a little bit bigger, but it's just a 2D sketch. Now I'm going to right mouse click on my component, and I'm going to the nesting authoring. And what I'm going to do, right now it says, hey, I'm kind of assuming that because I see this visible unconsumed sketch that you're going to use it. But I haven't really told it to use. So I'm going to click on it and say, this is the feature I want to use. Now I can pick extrusion. I can pick something else. But what I'm going to do is I'm going to pick that sketch, and now it's using it. Again, because it's just a 2D sketch, it doesn't know the thickness of it. I'm going to come in here and say that the component or this sketch is 1 inch thick. So it uses the correct material. So I'm now going to hit OK. And now I'm going to save it. And then I'm going to close out the part. Now I'm going to go back to my nesting that I had. And as you can see, like we noticed when we updated the components in Tuesday's webinar for the web, to do the flat pattern, we had an update. So we're going to right mouse click on this, and then we're going to say start the extraction again. Again, it's only going to focus on things that it sees a change, or it had a red X or those type of things. So it's going to go a little bit quick because we're only talking about one part. Now we're going to hit OK to extract, and you can see what happened. It changed the orientation because there's a different source. Now, to you, it didn't really visually change, but if you actually cut this out on, you're in CNC router or however you cut this out, it would be a 1/4 inch larger on all sides. So that's one way how you can control that, hey, I want to make this part a little bit bigger, but I don't really want in the part to model it to show it bigger. I want to model it as finished dimension, and then I can use a sketch feature to make it, larger and use that sketch feature in my nesting properties. All right. We're going to go into, just like what we did on Tuesday, we're going to go in our process material, and we have all our information in here. All right. Again, there's 2 types in the process material. There's material, and then there's packaging. Just to reinforce, material is basically the physical properties of your raw material. Hey, it's wood. It has a density. This is the color I want to use for nesting. So you can see all these different materials that it's brought in. It has different nesting colors. You can change that whatever you want. Packaging is the size of the raw material. All right. Is it a 4x8 sheet? Those type of things. Now, the only thing that I do not like about how this works is that it remembers, so as it adds material, it remembers the last thing that you use. So for example, you're saying, well, how did it, how did it pick these sizes and those type of things? Because I may have been working on, the last time I did a nesting study, my last packaging that I put in was 24 by 48 inches and the cost was, $7. In this case, I'm really all set and ready to go. But if I had these different, I got maybe 3/4 inch cedar that it comes in a 2 foot by 2 foot panel. Maybe when it's 1 inch, I can get it in a 4x8. So I can control the size of that raw material. Also remember that a material can only be assigned to one active package, but a material could have different packaging. So for example, this material ID2 is associated. So if we go to material ID2, you can see that it's associated to 1-inch thick cedar wood. Now maybe when I get that cedar, I can get it in, 2x4 sheet, maybe a 4x8 sheet, so I can make all those packaging for that given raw material, but I can only assign it actively to one of those packaging. When we get into the study, you're going to see this more in the demo too, where you can say, I want you to use all these packaging as a viable solution when you lay this out, all right? But like I said, you can only activate one per material, all right? When we go into material, when we go to the nesting, you have the ability to control how that material is oriented on the machine. So you can say, and then I should say really in the nesting study, so you can rotate it 90, I'm allowing you to rotate it 180, 270, those type of things, or I can allow you to deviate. So you can say, I can allow you to go 10, and then how many increments. So you have a really control of how that material is handled on your machine. Material grain, the frame width, as we talked about on Tuesday, is associated to how much you come in from each side, top, bottom, left, and right. All right, so we're talking in this case it's 0.4, almost a half inch we're coming in. So it's designed for when raw material is not perfectly, squared or 90 degrees. It allows you to say, I don't want you to violate this area, and put it in. The item separation is how much space are you putting in between your components. Now, maybe in this case here, we would want to increase it, maybe we're cutting it out with a CNC router, so we have to think about the router diameter or the cutter diameter and so on, all right? Before we go a little too far, I'm on really material ID. Now, in most cases, unless your templates are different, I always associate material ID 1 as that generic material. Now, you may be using it, and that's fine. But in our case here, our materials are really 2, 3, 4, and 5. So I'm just going to go material 2. I'm going to go to the nesting. And I just want to make sure that, these are not set, because I'm saying that my material, I'm not allowing you to rotate it, all right? It's always going to stay 0 degrees. I'm leaving my material grain at 0 degrees. And my item separation, I'm thinking of, cutters and those type of things. I'm going to do a ½ inch, right? So I'm going to go to the next one, material ID 3, make sure everything is all the same. Just go through and checking just so we have the correct results, right? Now, in each of these packaging, we also have nesting as well. And this is the left, right, and top and bottom trim. What this means is it gives you more control of that frame width. Remember I said, whatever that value is, it automatically comes in from top, bottom, left, and right. What the trim allows you to do is to override that and say, I want you to come in maybe 1 inch on the left-hand side, 3/4 on the right-hand side, those type of things. So maybe when you put your wood product or your wood raw materials down the table, you have to put clamps down to hold it down to the table. Well, maybe in top and bottom, you don't have to worry about that, but on left and right, you have to come in more distance. So you can say, on my left and right trim, I want to come in 1 inch. What that does is because it's a greater value than the frame width, it uses that value. So between the frame width and these trims, whatever is the largest value, that's what it uses, all right? So in our case, if we left trim and right trim 1 inch, our top trim and bottom trim would be actually to the value of the frame width. So it gives you more control of how that nesting occurs on your raw material. Again, I just want to go down through the nesting, make sure all my information is correct, and so on. And there it is. So at this point, again, you would most likely you're going to be setting this up in templates, so you don't have to go and check this each and every time. So we're just going to hit OK. Again, just pre-information, but we're not done. We need to add more stuff to it. So, for example, every time we sell a round deck chair, we sell the coffee table that's associated to it. Now I need to do a nesting study on this, or I need to lay this out. Well, in this case here, when I right mouse click on here and say create nest, I don't want to add it to a new study. I want to add it to an open document. So I'm going to go on here and I'm going to add it to nesting 3. Because I have this already open, I can add that automatically to it. It's the same thing if I went back into nesting 3 and do the source file. But I'm just doing it right from the model. Now I'm going to hit OK. Again, it's going to add, if we scroll down as it's going, it's adding those components to it. Now, again, because this model didn't really have the same material definitions, it's bringing the information in it. All right, so we're going to say yes to it. Now, in this case here, we would be doing some extra work because to say, hey, this table, because it's 3/4, and if there's 3/4 cedar information on the Adirondack chair, we would want to be putting that on the same raw material. All right. For time's sake, so we can get into demo 2, we're just going to skip that aspect of it. Again, it's going through. It's going through. Hopefully, we're going to get the green check marks as we go through. And then once this is done, we're also going to say, hey, I've got some DWG information or I've got some DXF information that I want to add to this nesting. I don't have to go and open up the AutoCAD drawing, and as long as it, like I said, it meets those requirements up front. But we can just right from here, we're going to click on source file and add that DWG and that DXF information. So you can see it's kind of very open, friendly, that, you know, I can do it from the model, I can add stuff to it, or even if I have already saved my nesting environment, I went home for the day, when I come back tomorrow, I can start it up again and say I want to add to an existing document, those type of things. So it has a lot of upfront information that just makes it useful for you. Give it a second here while we'll go through this. Again, like I said, we're doing, because it's generic CAD, it takes a little bit longer. So we've got our green check marks. So we're going to go to source file. And as you can see, here's all the supporting files. So I can just say, hey, look for IPTs, DWGs, those type of things. So I'm going to go out to my location where my DXF and drawing is. So we got this information. Granted, these two components have nothing to do with an Adirondack chair. It's just something I pulled from McMaster-Carr. So I'm going to pick the DXF and then the drawing. Again, these are simplified versions of it. And then I'm going to hit open. Now, as we scroll down and look from here, it does not know what material is because, remember, it's just 2D information. It's AutoCAD. AutoCAD drawings and DXF does not have material definition. But at this point, I can go in and click on it and say, well, this is material ID 2, and this is 4. Again, like I said, you would be using templates. So and you're going to see in demo 2 where this material source is named, you know, has a name that really defines what that material is, because I don't right now. I know ID2 is associated to that 3/4 inch material, but I don't really know 4. But again, like I said, you would have your template set up. All right, now we're going to hit OK. And as you can see out here, as we zoom in, here's our DXF file that's brought in, and here's our DWG. Again, you have to be all simplified in order for the nesting. If you leave your title block and dimensions, it'll give you a lot of errors. All right. So with that, we're ready to go. So we're going to go in and looking at our nesting properties before we start out. Nesting properties is kind of like the properties that you saw from materials and the packaging. All right. It's going to say, all right, here's the material, here's the thicknesses, those type of things. the priority, like I said on Tuesday, do you want, you're in this case here, I'm giving 100% priority to everything. So lay it out whatever you want. But you can say, hey, I want these components always to be cut first, so you can give them a higher priority and set the lower priority on the other components. The orientation, this is how it's coming in, all right? We're going to see once we're done here, the nesting study may not be what you want, and you may say, all right, I've got to orient this part a little bit different just so that I get a better nesting study. So initially it's coming in at 0 degrees, but I may want it rotated 90. Then we get in over to the binding operations. Right now, this is all grayed out because it's bounded to the material information. But if I unclick any one of these, I can say, I'm giving you the authorization that you can rotate it 90 degrees, you can rotate this part 180 degrees, 270, or again, like I said, deviation and what that increment is. So you can say, start out 10 degrees and then increment it every 5 degrees to give you the best results for it, all right? In this case, we're just going to leave everything as is, but we can change this information prior to we run the study. Once that study is done, we can still go back and change that information, all right? So now we're done. We're going to hit Create Nesting. This is the information because we're all using, all these components are all using all these packaging, all that information is part of this study, all right? But it doesn't mean, it has to maintain, if this component is assigned to this packaging, it must maintain that, all right? Our name of our study, there's 2 types of studies that you can do, is single or multi-value, all right? So in this case here, because we have it set to a single value 1, we're making 1 chair, 1 table. I could go multi-value and say, hey, for this order, we're making 2 Adirondack chairs and 1 table, so whatever that combination is. All right. As we pointed out on Tuesday, this is our global nesting parameters at the bottom. What are you starting? Where's your 0, 0? In our case, we're just going to leave lower left. What is our performance? So you can set a minimum runtime, meaning in this case, this value of 60 seconds means that you have to run the nesting study at least 1 minute before you can start spitting out results or think of results. I can also set the max runtime, all right? At some point, if it's exceeding beyond that, then it's going to spit out the results. But based on your complexity of your layout, it may, it may run a little bit longer than you expected. The desired yield, as I stated on Tuesday, this is what you have to achieve before you bring in another raw material to start continuing that laying out. So you at least have to achieve 80%. Now you can set that, to whatever you want, whatever that yield needs to be. And then the optimization is most people leave it on the minimum length and width, but you can toggle it to minimum length, minimum width. So, whatever you want to do, but, it's whatever how you want to configure. All right. So we're going to now hit OK. If we go over to the Calculate Nest, in this case, we've got some issues. All right. These three components there's something wrong with them, but we'll look at it later. So in that, we didn't really see it. It was quick enough to go through it. But if you had, a larger component or a lot more components, you could toggle over the Calculate Nest and see the progress like we saw on Tuesday. All right. So we're going to scroll down to our bottom, and we're going to see why we have some issues. So the study, this Nest 1, Nest 3, and Nest 6 has some issue because I know it's kind of hard to see. There's a little triangle here with a exclamation point in. So if we hover over that, it tells me that, hey, these parts may not fit on any nest. And here's the reason why. When we zoom in here, these components are the same. They are actually 24 inches wide, the same as our raw material. Now, in your case, you may be fine with that. If not, maybe you have, limit capabilities or those type of things, because we may have violated that frame width, those type of things. we can go and turn that 90 degrees. It's up to you however you want, however you handle the situation. But these are the reason why we were getting a failed issue. Now, as I stated before, this is the back of the Adirondack chair. It was one part file, but multi-lump. And as you can see, it understood that those multi-lumps are, in theory, different parts. So it actually did, which I thought was a kind of a cool thing. Thinking, oh, well, this is not going to work because it's a multi-lump, a single part file, that it would try to look at it as one big part file. But as you can see, that it takes care of it. So just to quickly, we can fix this issue. We can go to that part. So we know, we know that it's part 5. So I can scroll down here and say, hey, it's part B. All right. So here is our part B file. What we're going to do is we're going to open it up. Oh, sorry, wait a minute. Sorry, I didn't mean to do the opening of it. We're going to go in to this nesting study of Nest 3, and we are going to click on it. Oh, that was, sorry. Nest 1 had our issue. We are going to go in and edit. We are going to find this part B here, and we are going to change its orientation of it. So we're bound to the material, so we're going to unbind it, and we're going to go and say, I want you to turn that 90 degrees. Now I'm going to hit OK. It's going to go back and automatically do it. As you can see, it still says Nest 1 has an issue, but in our case here, because it's just that other component that's associated, you can see that it's turned with a couple clicks. It's changed that component and turned it 90 degrees. It's still failing because maybe this one is, still having issues, those type of things. But you can see that even though we did a study, we went back in and changed that environment or those settings to adjust to turn that 90 degrees. Because if you look at these other ones here, those type of things, that there may be something that, we're losing a lot of space here. Maybe we want to turn these 90 degrees. Maybe we want to think about maybe investing in or looking to see if we can get larger material, those type of things, because it may all impact the grain direction, those type of things. But it's a nice visual aspect of looking at that study and seeing, like, for example, here, I mean, yeah, we had to go out 3 sheets. Is there something that we could do in the settings to control to make sure that we're using this part of that raw material, all right? So sheet metal, it may be a little bit easier, when we looked at the toy truck, because we're looking at smaller components, but think about that when you start getting larger components. In addition, what I want to wrap up for this demo 1 is that reporting capability. So each one of these nesting studies has the reporting. So you just double click on it, and it shows you, it brings up HTML. Like I said, you can save this, you can print it, those type of things, and gives you an individual report of the information. Now, these are customized. You can see that's a reporting template. I'm not going to get into how to set up those templates and those type of things. But again, I have the information, shows me all these components, how their settings and those type of things, and that's where you can start looking and say, all right, let's see if we turn this 90 degrees, or maybe we allow the material to turn 90 degrees. You could get different results. Again, like I said on Tuesday, I keep going back to the Tuesday's webinar, but this is my favorite out of the report. I can visually see in that given raw material or that package for this given sheet how much material or cost associated to that given part is using on that given packaging. So I think it's a useful to say, hey, part G takes up, almost half of that material. Is there something that we can redesign to make it less, use less material, those type of things. All right, so we're going to close that out. So that's basically a look at Inventor nesting, not as sheet metal components. So think about that. like I said, a lot of people think Inventor nesting is just tailored toward sheet metal. In my opinion, it's not. And you're going to see this in demo 2 that I'm going to start here shortly, where I'm using it a different way, kind of thinking out of the box and say, I'm not really thinking about nesting. I'm thinking it as a different approach. All right. So I'm just going to close this nesting out. I'm not going to save it. Again, like I said, it is a separate file that you must maintain. And what we're going to do is we're going to toggle back over to our presentation. And for demo 2, I'm going to use it as what I call the saw cut method. All right. I'm into some woodworking. I'm no expert. It's more of a hobby, whenever I can get to it. But when I look at things and, on the web and it says, hey, the build dish you need, and I'm thinking more for this demo of, 2x4s, I'm going to cut. So they give you a cut list and they may say, well, you got to buy this many size 2x4s, this length, and those type of things. And I always, in the back of my mind, say, did they really do this in an efficient way? Did they just go buy a whole bunch of 2x4s and just start cutting and, hopefully they're not, making a lot of scrap? So in this example, I'm going to use Inventor Nesting to kind of control it to see the most efficient way of, in this example, cutting 2x4s to make this frame. So in this project, you can see the 2x4s that's required. And the cost based on my local hardware store, it's going to cost me $42 if I take their advice and go and use what they say to use, all right? So we're going to toggle back over into Inventor. And before we get into running a nesting study on this frame, I want to jump in and talk about the Inventor template. So what I've done is I've created an Inventor template associated to my 2x4s. And mainly if I go into my process material library, I have a material in here called wood 2x4s, all right? And based on my local hardware store, I can buy in 6-foot lengths, 8-foot lengths, 10-foot, and 12-foot. Now, most common, when people buy 2x4s, the most commonly stocked or the most volume stocked is 8-foot. So I've used that as my active package, all right? The other thing that I've done is when I'm in my nesting for material, what I've done over here is we need to set our separation of, we're going to set it to 0.25. And the reason is I'm thinking of the saw blade. When you're cutting, you're losing that material. It's there. Whether your blade is an 1/8 inch, a quarter, whatever it needs to be, I'm just giving a little bit extra material there. I'm not looking for accurate, right to, 10,000ths of an inch to the end of the 2x4, but at least gives me an approximation of, hey, I'm laying this up most of the effective way, all right? And then for the packaging, what I've done is I have to fake it out, all right? If a 2x4 is 1x5 by 3.5, and then, 8 foot long, what I do is I make the width of 1/2 inch bigger. So instead of saying, hey, this is 8 foot by 3.5, I'm really making 8 foot by 4 inches. And that allows the nesting to work properly without giving all the, warnings and errors, hey, this is not going to work, those type of things. So I'm kind of faking it out. In the nesting aspect of it, I am going to, so if I go back on to my nesting here for the frame, I set my frame width to 0. I'm saying you're allowed to go right out to the edges, right? This gives me the best results for doing this, all right? So going back to the packaging, in my nesting, I am going to come up from the bottom 1/4 inch. So basically, when you see the results, you're going to see the 2x4 that I'm cutting in that material that's a 1/2 inch wider to be centered, all right? It's just more of a visual aspect of it. Again, I'm faking out Inventor nesting to do this. So I just want to make sure that all my nesting information is set. 1/4, like I said, it's building my template, just double checking for it. And when we go in the material for the packaging, I have the dollar amount for what that 2x4 stud at that given length cost at my local hardware store, all right, whatever, wherever you're getting it from. So that was the template. So we're going to use this template as the starting point for that, all right? It's basically, you're almost like doing a study. You just see how it flashed real quick because it thinks that you're doing a study. So I'm going to save this, and then I'm going to close it out because we can't use a template while the template is in memory, all right? So here's the wood frame. Really not, a lot to it. But what I'm going to do is now I'm going to right mouse click on here and say create a nest. Again, we're going to use a template, but we're going to use something that we've already we've done. So I'm going to use this template that I've defined, and now I'm going to hit OK. Same thing, it's going through. But in this time, instead of it defining the material on its own, it's going to use the existing material that's there. Now, you say, well, Mark, you just said that, so why is this prompting that this is 10-inch long, right? For example, we're going to see here there is a component on this model that when I drew the 2x4s for that, remember I said I draw it by the rectangle 3.5 inch wide by whatever that length of that wood stud needs to be for this frame. I've added another stud here that I created while in the assembly, so it was drawn from the end of the 2x4, right? So I sketched out as 1.5 by 3.5 and extruded 10 inches. Remember when I said that Inventor part file, if it does not find that unconsumed sketch, it looks for that first extrusion. So it thinks that extrusion thickness is 10 inch, but we're gonna adjust that here in a second. So I'm just gonna say yes, and if we scroll over here, you can see that it's picked up my material, so it knows all these components are associated to this material wood 2x4, except this one component, and then it's set to the material ID of 6. All right, we're gonna correct that in a second as it goes through this transformation. Give it here a few minutes. Again, green arrow check mark, so we're good. So we're going to hit OK. Lays it out. Now, every one of these, to my eye, because I modeled this, looks correct, except this last, sorry, scrolled the wrong way, this last 2x4. Again, remember I said it thinks this material is 10 inches. It thinks that's what it needs to be, and this is what you're going to be cutting out. So what we're going to do is we're going to go back over to nesting. We're going to go to this file here. We're going to right mouse click on it and say open. And we're going to right mouse click here and we're going to say nesting authoring. It is set to an Inventor part file. We are going to change this to Generic CAD. And as we did that, it changed it to 1.5 because remember what I said, when the provider is Generic CAD, it looks for the largest planar face, which is going to be this face right here, and then does geometry extents and finds out that its thickness, its other face, is 1.5. So we're going to hit OK. Now we're going to save the file. And we're going to close it. We go back to our nesting. Again, we made a change to it, so we're going to right mouse click on it. We're going to start the extraction again. Should go quick because it's only that one file. Now we're going to hit OK. And you're going to watch, then it flipped because it now knows that's the correct orientation. So you can see that even though that it picked something or assumed something, that's not what I want. I can go back to ability and change it. All right. Now in this case, I'm not going to get into nesting proper. We're running out of time here, so we're just going to go right into creating the study. So when I ran this, you can see that we have our 8 foot because it's assumed that everything is going 8 foot. So what we can do is we can go in and add these additional properties to it. or these additional parameters saying that even though that you're associated to the 8-foot 2x4, I'm giving you the permission to use the other ones as needed. All right. So we're just going to do a nesting study real quick, just a second, and we're going to hit OK. All right. We've got it says that there's an issue here. We'll look at it. So we're going to go through, and it's done a nesting study. And in this case, it's going to cost me $43. And I'm like thinking, oh, that's actually more than what, the study, when I, took what that person said, it's going to cost me $42. And you're like, okay, I guess they were efficient. Then I realized what they were talking about. They are talking about they use more 10-footers than they actually did 8-footers. So our study is based on the order in which those are listed for those packaging. So let's go back in. So we're going to click on this study again. We're going to go back to edit, and we're going to go back to the 10-footer, and we are going to put that at the top. So I want you to go 10-footers, 8-footers, and so on. Now we're going to hit OK again. Let it redo the study again. Give it a second to calculate. Again, we have that. We didn't look at that, but we'll look at it here shortly. When we go in, based on nesting, based on what it's using, I can make it cheaper by nesting. I mean, yes, we're only talking in like $3 and something, but if you were making a whole bunch of these frames, you can see that whatever they told me to do was not the most efficient way. And as you can look here, now there is some graphical issues here. I need to get with Autodesk to see why it's causing it. But as you can see on this 10-footer, this component here is actually 10 foot long. So that's why it's telling you that there's an issue, because in theory, you're not actually in a nesting study, you're not actually cutting this. You buy a 10-footer, you need a 10-footer, you're not doing anything on the saw. But as you can see here in this component here, again, I can cram these components in here with a 1/4-inch gap. I can cut all 3 of these pieces on a 10-footer, all these components on a 10-footer, and here's I'm left with about a 1/2 inch. So you can see how efficiently this is compared to just kind of like putting a 10-footer down on your saw and measuring out and cutting. You can now use this and say, hey, when you cut this up, this is how you should cut it up based on this nesting study. All right. So I looked and said, can this be done a little bit cheaper? Like I said, we're running out of time, so I'm going to go through this a little quick. So we're going to go and create another study. We're still in the same nesting study. Down here is the material use method, all right? And you can toggle that in. So again, we're going to go and add all our 6-footer, 10-footer, and 12-footer. And this time, we're not going to say as listed. We are going to say the best mix. Now I'm giving it more opportunity to say, based on what it is, you pick and choose what you want to do. So one cut may be an 8-foot, one cut may be a 6-foot, and those type of things. All right. So we're going to hit OK. It's going to do the nesting study again. We've got an issue, and basically that issue is that I am saying that, hey, I have a 12-foot, I have a 10-foot and a 12-foot beam in my model. Yeah, I'm just I'm just buying a 12-foot and 10-foot. I'm not cutting it, but for nesting things that you are trying to cut it. All right, so in this case, we're just going to hit close, go through that study again. Now, in this case here, it actually turned out a little bit more, all right, based on the study. So you can look and compare how that is impacted if I do a mixture of it. So in my case here, if I was going to go build this frame, I'm going to look and say, all right, I've got to buy this many 10-footers, this many 8-footers, I might be behind a 6-footer. Instead of always focusing in, when I used to do these projects, I would say, oh, okay, I need, 10 8-footers. Well, maybe in theory, I only needed 6 8-footers. I might have got away with one 10-footer to make, the overall cost a lot cheaper. Again, this is kind of thinking outside of the box. It's not really a true nesting environment that you're doing, but I think it's a unique workflow that I can use nesting to do something else.